All right, guys, we're back. This will be part two of working with Windows and command line interface. This is the other part of the table I didn't show in the first part, but that's okay. It's all one lecture. I just broke it up for your guys' sanity and mine. So here you can see non-resident files and files that are smaller than 5 total gigs we talked about. Starting non-resident attribute is 80, so it's here. Pointing my finger as you can't see. Let me get the mouse here. Let me move me here. And then here is the length of it. It's 48. So not too short, but not too long. Attribute, non-resident flag, there it's there. Starting point of the data run is here. That's what that looks like. And the record marker, sorry, is here. The starting point is D, which is here. Sorry, 31, my mistake. So moving on. Let me bring up the slideshow tools so I can keep going. So when a disk is created as an NTFS file structure, OS assigns logical clusters to entire disk partitions. So what does that mean? So an operating system assigns logical clusters to entire disk areas. Partition. So if it's a whole terabytes partition, it's going to assign cluster areas to everything. And that's essentially it. These assigned clusters are called logical cluster numbers. Become the address to allow the MFT to link to non-resident files in the disk partition. Pretty straightforward. When data is written, it's first written to non-resident files and LCN addresses, which is logical cluster numbers, is assigned to the file. The LCN becomes the file's virtual cluster number. So it's become represented for virtual items. I'm sorry, stuff is so dry, guys. Where the header of all MFT records, the record fields of interest are as follows. At the offset of 00, MFT record file identifier file. The offset of 1C to 1F, size of the MFT record. So that tells you how big the size is. The offset of 14, I'm just let's say 0x. So link to the header indicates where the next attribute starts. And I think of it as like a tab marker, bookmark. And offset at 32, 33, so it's only within those two areas. The updated sequence array, which stores the last 2 bytes of the first sector of the MFT record. Here's what that looks like. The record identifier is here. It's right here. It tells you. Link to the record's 38. This data goes into position offset IE and IF. Don't worry about that. Size of the entire MFT record is 4. And note, this data is swapped with in position IE. Okay. You're not going to really use this that much anymore. Well, you will, because NFT is standard now, remember, technically on everything. Here's what the 10 standard looks like. This is going to go over a bunch of standards. So attributes here, we said 10, last state modified. You would decode this. Is all. See this on the right? That's all hashed, technically. Size of the file is 60. That's the attribute. Last access date time, this here, you would have to convert this. Record update time is F8, and that would be all this gobbledygook converted out. But you would use a decoder, a hash reader to do this, which what those recording systems can do. Oh, good lord. Dinner's still kicking in, guys. So here's another example. I'm not going to go over it, guys. It's just a bunch of attributes for short and long file names. If you're curious, read about it. But attributes of 30, short file name 80, or C, create date and time. It's just same things I just covered. Short last updated. Yeah, it's okay, guys. It's a bunch of stuff. Don't worry about it. It won't be that much on the exam. This is just how this format file system works. It's just really hard to decode it. That's the thing. Or not decode it, but describe what it is by looking at it. It's very hard to see. But once we do it in practice, you'll see what this was referencing more. So moving on. Attribute 40. Starts size of attribute 40 is 28. Start off the position for GUI ID data is 18. Start position for GUI ID data is F6. And it runs all the way down here. There's a bunch of figures. Attribute 80 data, the resident file I talked about. This is the size of the attribute is 78. Number of bytes allocated data is 5A. I'm not sure what that translates into. Sector checksum, so in case there's errors, swap things out. Start of resident data run, resident flag is 00. Another one. Size of attribute 80 is here. Here's 80, so we know it's that. Size 60. Non-resident flag, so we know it doesn't belong. It's bigger than what it's supposed to be, so it's at C, which is here. First data, first date run is here. 32nd, whatever that translates to once it's translated out. Second time it was used was 22nd, whatever the 22nd translates into. Additional times it was accessed was F. It's all these here. And the last time it was used, 00. And the MFT record, that's the end of the record for it. Sector checksum is I there, and then sector boundary is here. I know, guys, it's a lot of stuff. So let's talk about alternate data streams for a second. Ways data can be appended to existing files, so how to tax on more data to it. Can obscure viable inventory data intentionally or by coincidence. So you kind of add files on top of files and like bury it, almost like sand. Pile of sand high enough, it's kind of hard to get to the bottom of it. Well, metaphorically speaking. For example, you have a bucket, you fill it with sand, you want to get to the bottom. How are you gonna do it? You're gonna dig out little by little, scoop it out, or you just force your hand in, and it's gonna get stopped because of the sand, regardless. It's not gonna be completely visible, if you know what I mean, or reachable. Sorry. An NTFS, an alternative data stream, becomes an additional file attribute, allows the file to be associated with different applications. So that's if a file is shared, across multiple items. Try to think of something that could relate to. Kind of like, oh, here's a good one. Say you have an MP3 with your favorite song. You could open it either Windows Media Player or VLC Player. That's where that would count, or that's what we're referring to, would be associated with different applications. So they can open it with either. You can only tell whether a file has a data stream attached by examining that file's MFT entry. So we'll do stuff like that. Don't worry. Here's what that kind of looks like. So start of data run for second attribute is here, 68, 80. We know that's there's a size 58. That's what that looks like. So NTFS provides compression similar to FAT drive space 3, a Windows 98 compression utility. That's ancient now in today's speak. With NTFS, files, folders, or entry volumes can be compressed, so it makes things compact. Most computer forensic tools can uncompress, analyze, compress Windows data. So keep that in mind. Let's talk about encryption and NTFS. Encrypting file system introduced in Windows 2000 implements a public key and a private key method of encrypting files. So a public key is a key that you have that you can give out to everybody to decrypt the file, and the private key is the only key that you would have, or that you only have within your organization, that only it works there, it can't work anywhere else, or isn't given out to anyone outside of your department or your team. That's a private key. A public key is the one you can hand out. When EFS, encryption file system, is used in Windows 2000 or later, a recovery certificate is generated and sent to the local Windows administrator account. Users can apply EFS to files stored on their local workstations or a remote server. Yeah, this is like cutting edge, like 23 years ago, but let's face it, even that's kind of archaic now. Everything now is all about hashes and SHA 512, 256. I think 256 was broken a while ago. I mentioned it. So now it's like SHA 512 is what's used. So it's broken, but I don't know how long that's going to take. Recovery key agent implements the recovery certificate, which is the Windows administrator account. Windows administrators can recover a key in two ways, through Windows or from a command prompt. Command cipher and copy. When a file is deleted in Windows NT or later, like XP, which is now even more archaic, you can even say 10, the OS renames it and moves it to the recycling bin. So you've done that, right? They use delete ms command, eliminates the file from MFT listing in the same way FAT does. So resilient file system, REFIS, designed to address very large data storage needs, such as the cloud. That's where this is mostly implemented. Features incorporated into REFIS design. Maximize data availability, improve data integrity, designed for scalability. So if the data gets too big for it to handle, you can just tack on more space and just spread it out more, or allocate more sectors of hard drives. SSDs in this case. REFIS uses disk structure similar to MFT and NTFS. In recent years, there has been more concern about loss of personal identity information, PII, and trade secrets caused by computer theft. Particular concerns of theft of laptop computers and handheld devices. To help prevent loss of information, software does not provide whole disk encryption. That's more about encryption. We're just talking about encryption, okay? Current whole disk encryption tools offer the following features: pre-boot authentication, where you need a password or a key, or a USB key too, even physical key. Partial disk encryption with secure hibernation. So when you go to sleep, it would secure that part of the hard drive can't be accessed until it's rebooted or allowed in with the key. Advanced encryption algorithms. Sorry, that's what you see more now with SHA 256 or MD. What the hell is MD at now? I don't remember. 128, I think. Advanced encryption. That's mostly used now. Key management function. You can manage keys with a separate account. Whole disk encryption tools encrypt each sector of a drive separately, so each is its own unique encryption. Many of these tools encrypt the drive's boot sector to prevent any efforts to bypass a secure drive partition. Remember we talked about the write, so it gets locked out? That's what that's referring to. That's what you use, something that goes in between it and stops it from the boot drive, from booting in the sense of boot locking. That's what that refers to. To examine an encrypted drive, decrypt it first. Write a vendor-specific program to decrypt the drive. Many vendors use a bootable CD or USB that performs for a one-time passphrase. Yeah, those exist. Don't worry, I won't have you do this on your Windows machine at home. You'll break something. I don't want to go there. So, available Vista Enterprise Ultimate Windows 7, 8, and 10, Professional Enterprise and Server 2008 or later. The thing is, excuse me, a lot of these programs, I mean, I would argue 7 and 8 are going the way of the dodo, and 10 might be on its way out within the next 2-3 years, but give it some time because everyone's trying to shift to Windows 11. Server 2008 it's sunsetted already. Now they're on 2012, they're about to sunset. And I think the last thing Microsoft is going to support is 2018 or 2 to the newest version of server, which I think is 2020 or 2022. And that's it. After that, they're going to slowly whittle away and make you go only use one platform. Hardware and software requirements for this kind of stuff. A computer capable of running Windows Vista or later, so being like a modern basic computer. The TPM microchip version 1.2 or newer. Man, everything's 1.4 or newer. A computer BIOS in line with trusted computing group. That you have to talk to the manufacturer. That might be built in. 2 NTFS partitions, so you just put in 2 drives. The BIOS configured so that the hard drive boots first before checking other boot. Yeah, that's something you set in BIOS regardless. So here's a couple of third-party encryption tool examples. Endpoint encryption. These are for Western Digital utilities. Endpoint encryption, voltage secure files, and Jedico Bscrypt volume encryption. That is a mouthful, guys. So let's jump into the registry. What Windows here. Oh, sorry, guys. Dinner's still kicking my butt. So registry. What is the registry? A database that stores hardware, software configuration information, network connections, user preference, and setup information. To view the registry, you can use regedit, which has been built into Windows since what, like 95 up. So you still have it to this day. Regedit 32 for Windows 2000 XP Vista. Both utilities can be used for Windows 7 and 8. If you've never seen what it looks like, let me run it, and you'll see. So you type in run regedit. It came with the prompt, and that's what that looks like. This is all the classes, roots, and this is all key values and stuff. So this is what I'm going to be talking about. Okay. Let's move on. So here's the terminology. Registry, registry editor, which is just the reg edit. H key, which is there. Key, subkey, branch, value, default value, and hives. Hives are things you can edit with specific things like Hiren's boot CD, and that's how you can move passwords from machines. Might even do that on a virtual machine or something. Maybe. I'll think about it. So here's registry file locations and purposes. User accounts, nt user.dat. User protected storage area contains a list of most recent user files and desktop configurations. That would be considered metadata. Windows System 32 config default.dat contains the computer system settings. Windows System 32 configuration sam.dat contains user account management and security settings. Windows System 32 configuration security.dat contains computer security settings. That's like 2 security ones in here, huh? Windows System 32 config software.dat contains an installed program settings, associated username and passwords. Okay. Windows System 32 configuration system.dat contains additional computer system settings. Windows System 32 configuration system profile contains additional NT user information. That's network stuff. So here's what that looks like, which I just popped up. I'll bring it up right now. It's no big deal. So you'll see it's what it's going to look like. Render, yes. They're under, where are we under? Computer? Sorry. I should have you guys see it. Yeah, see, that's all this, guys. So I go on to the next one and talk about that right now. Let me pull this back up. We're talking about HKey class root, this guy here. A symbolic link to the HKey local machine software classes provides file type, file system information, URL protection, prefixes, and so forth. So essentially within this, there's all this. So that stands for it there. HKey current user, a symbolic link to the HKey user stores settings for current logged in user. Here's all your profile stuff, your settings, your pictures, your settings, your background preferences, all that stored in here. Local machine, this guy here. Contains information about installed hardware software. So everything installed, like your graphics card, your CPU, if you installed Steam, Office, all that stored in here. HKey users. So it's the one under it. But that all has files too. But let me go back to local machine. That's what that looks like, if you're curious. So it's talking about users. Stores information for the current login user. Only one key in the HKey is linked to the HKey current user. So one key from here is linked to here. That's how they talk to each other. So next slide. And HT create config. That up again. I'm just using an example so you guys can see. So this guy. Symbolic link to HT local machine system. So it talks up here to this one. It goes in here, it goes to here. To this one. That's these all talk to here. Controls current hardware profile with XX representing the current hardware profile. Contains hardware configuration. It's just your hardware settings. HKD and data used only in Windows 98 or ME system store. That's ancient. Don't even worry about that, guys. So let me close this. So that's what that looks like. So let's jump over. Tools with built-in or add-on registry viewers. So you can use X-Space Forensic, OS Forensic, which you have. Forensic Explorer, which we may touch, I don't know yet, and FTK, which we still need to finish configuring. Don't worry. So we might do something with the registry of your machine just to scan it. I'm not going to have you delete it or modify it. Don't worry. Again, my whole point is for you guys not to damage your machine. If you would like I said, install the Windows virtual machine and we can go from there. So almost there, guys. 15 slides. So see, that's what a key looks like. You can tell it to find these are the values for all of it and what it does. So that's that person's email. It's probably their profile. See all that gobbledygook? That's all it looks like it's hashed. So that looks like. So under starting Microsoft startup tasks. So when you start at Microsoft, everything that comes up. I'll load mine too. Learn what files is accessed with Windows Startup. This information helps you determine when a subject computer was last accessed. Report with computers that might have been used after an incident was reported. You can find valuable information. Windows 8 and 10 are multi-platform OSs. Can run on desktop, laptop, tablet, smart. It runs on practically anything essentially. Well, with hardware reasons, as long as it works hardware, it'll run. The boot process uses the boot configuration data BCD store. BCD contains a bootloader that initiates the system's bootstrap process. So that's what tells it to launch Windows, load Windows. Press F8 and F12 when the system starts to access the advanced boot options. F8 was what used to get you into recovery mode, and F12 is so you can network boot. So you can load from a network and image or do what you need to do. But F8 doesn't really work anymore in that sense. You have to do a different way about going about now. I think it's if you restart, you hold shift and it gets you to safe mode or last long good config. That's what F8 used to do. All the TFF computers perform the following steps when the computer is turned on. So when you turn it on, it posts. Power on self-test. It checks to turn on and sometimes beeps. It hasn't done that in a long time anyway. Probably phased it out or got rid of it. Initial startup. So make sure it loads. Then goes to the bootloader and loads Windows. Detects the hardware in your configuration. If the kernel for Windows is loaded, then you can log in. Start files for Windows Vista. And it's still similar to Windows 10, believe it or not. The NT LDR program in Windows XP used to load the OS has been replaced with these distributed tools: Boot Manager, WinLoad, and WinResume. I think WinResume has been axed. I could be wrong. I know Boot Manager and WinLoad are still there. That's what they kind of built it up from. Sorry, Windows Vista includes the BCD editor for modifying boot options and updating the BCD registry file. BCD store replaces the Windows XP boot.ini file. Yeah, that's the truth. Ini is that .ini file is kind of gone. This is what the Windows XP loaders look like. Maybe some of you have seen it, maybe some not. That's okay. So that's what they look like. Device drivers contains instruction of the OS for hardware devices. I mean, Windows XP was very popular, guys. You still find it laying around some places off a network, though. If it's on a network, it's a pretty big vulnerability. But this was standard for like, God, how long was it? Well, 10 years, I think XP was around. Like, commercially supported. It was something. It was really good for what it was. So here's what that looks like. I'm not going to go over them that much because they're not really that relevant anymore. These right here, I think it's in 32. It's part of the Windows 32 subsystem, which is system 32. So NTLDLL supports service dispatch, loads to executable functions and additional support functions. Hardware stack layer, scratch earlier we talked about it. Physical address supporting programming is a RAM. So if you had more than 4 gigs of RAM back in the day, this is what took over. Actually, this was the kernel for Windows itself. There. Almost there, guys. 8 more slides. Contamination concerned with Windows XP. When you start Windows XP and TFS workstation, several files are accessed to me and the ones I listed prior in that table. Last access date and time stamp for these files changes to the current date and time, which makes sense, right? You turn it on, you're accessing it, it changes now. Destroys any potential evidence that showed when Windows XP workstation was last used. That's the downside. Virtual machines. Let's talk about VMs for a bit. This is something, if you've had networking with me, we played with VMs a lot. So you'll be a little bit familiar. If not, it's okay. We might implement one. It's not hard. It's pretty simple. I will give you the tools. I'll tell you how to do it. We'll do it together. So Virtual machines enable you to run another OS on an existing physical computer known as a host computer by emulating a computer's hardware environment. So you can calculate how many cores for your processor you want to use, how much RAM you want to use, how big of a disk space you want to use. Remember I talked about Bob, and Bob died, and I used Bob 2, then Bob 2 died, and I used Bob kernel. That's what my virtual machine is called, but it runs Windows. Just because it's, no files on there, it's real bare bones. I can break it and I don't wreck my personal machine / work machine. A virtual machine is just a few files on your hard drive. Must allocate space to it. I usually use 50 gigs. So a virtual machine recognizes the components of the physical machine it's loaded on, and virtual OS is limited by the physical machine's OS. Kinda, you can specify how much of each resource it gets, even up to your graphic card. I do a basic 100 megabyte video card that doesn't exist. Technically, it's just a virtual thing. Here's what that looks like. Digital thing, sorry. See, that's what a VM looks like. In digital forensics, virtual machines make it possible to restore a suspicious drive on your virtual machine and run non-standard software that suspect might have loaded. So you would load that machine in there and you would have it scanned or do what you need. For a network forensic standpoint, you need to be aware of some potential issues such as virtual machines used to attack another system or network. Yeah, that's something they used to do or still do from time to time. Common applications for creating virtual machines: VM Server, VMware Player, VMware Workstation, Oracle VM VirtualBox, Microsoft Virtual PC, and Hyper-V. Hyper-V is more of an industry standard that they use in private and public sector. VMware is very popular too. Microsoft Virtual PC, I haven't really played with. I most use Oracle VM VirtualBox because it's free for you guys and free for me, so we can play with it. See, using VirtualBox, open source program. Download that. We'll worry about that later. Don't worry about the VirtualBox activities. We'll get to it. This is what they want us to do. So here's a summary of what we're doing or what we covered. When starting the suspect's computer, use boot media such as a forensic boot CD or USB drives, which I talked about. You must ensure that disk evidence isn't altered, so you would check and scan it and make sure the last day alter matches to what's on the drive and the day and time. So if it's the day before, that's the last time you use it, that's the last time they were there, cool, you're good. If it's now, something changed, and that's a problem. Master boot record stores information about partitions on disk. Microsoft used FAT12, FAT16, and older operating systems, which you don't really see that often. 16 was around for Windows 95 and 98, from what I remember. To find the hard disk capacity, use the cylinder's head and sectors calculation. You could, or you can check properties on it, or look at the packaging. So, summary slide 2. When files are leading in a FAT system, the hexadecimal value 0x05 is inserted in the first character of the file in that directory, so it moves it out of the way and it can write over it. Remember that. NTFS is more versatile because it uses master file table, MFT, to track file information. Yes, it's a lot more flexible. Records in NFT contain attribute IDs that store metadata about files. Remember we said capture all the metadata? That's part of it. NTFS alternative data streams can obscure information that might be of evidentiary value. Remember they had a whole bucket full of sand. You try to get to the bottom, you just stick your hand and you can't get to the bottom. You got to dig out little by little. So you're essentially doing with that. You got to dig the data out and just slowly take it apart. File slack, RAM slack, and drive slack are areas in which valuable information can reside on the drive. NTFS can encrypt data with EFS and BitLocker. BitLocker is more common. EFS is phasing out. NTFS can compress files, folders, and volumes. It does that. Windows Registry keeps a record of attached hardware, user preferences, and network connections and installed software. That's why that's important. If you were to scan that and see what's changed and what hasn't changed, you can see what they have or have installed and haven't installed or removed and try to hide. Virtualization software enables you to run another OS on your host computer. So that's all for the second part of the lecture, guys. I will see you in the next one. Have a good one.